Hey everybody, welcome to The Index. I'm your host, Alex Kahaya, and today I'm excited to have Jin Kwon, who is the co-founder of Saga, which gives visionaries the high-end tools and support they need to turn their Web3 dreams into reality. Saga is, and I'm just going to pull this up off of your website here, the complete Web3 platform made for developers. And I want to learn more about what that means, but first, tell me a little bit about yourself and kind of how you got into the space and really why you're building what you're working on.
Yeah. Let me go chronologically, actually. So I was originally an engineer a long time ago. Studied computer science and then did my master's at Berkeley, essentially doing research around like computer architecture and systems designs. Essentially, my work was around like silicon photonics. So it's like when you replace electrical channels with light channels on chain, how do you re-architect how computer architecture looks like? Because a lot of design decisions in computers have been optimized for electricity over decades and decades of design, essentially. And so this was like kind of an interesting kind of pivot point where people were like, hey, let's see if we can bring light channels all the way down to on-chain and see if you can replace that. And then what kinds of broader architectural decisions can you make to change that? So worked on that during my grad school years and then went to Intel and I was doing, computer architecture stuff for a little while. I worked in engineering for just a little bit, and then I quickly realized that I wanted to learn a little bit more about how the world functions in a higher level. So what I learned is as you go deeper into engineering generally, you go deeper and deeper into like a singular vertical and you become more of a master of like a singular kind of topic. And I wanted to go broader, essentially. And so I shifted into like kind of more of a business role within Intel. And then afterwards I went to business school and then I popped out on the other end as an investment banker. So I did technology investment banking for a few years, just kind of learning about how giant mergers and acquisitions function in the tech industry and how all this works essentially as human and as financial kind of numbers in the background. And I actually discovered blockchains and crypto kind of accidentally. So my brother is the founder of Cosmos, so his Jin Kwon. One day he was like, he always had like really interesting kind of crypto startup projects that he did, but usually they were like one or two people or pretty small. And then he came to me and was like, hey, do you want to come help build Tendermint, essentially, which is the company that built Cosmos and a lot of the Tendermint protocol underneath. And he was like, oh, there's like about 10 to 20 people essentially working on this. So I was like, oh, this is actually kind of something similar, something serious, essentially. And so I looked into that. And I had no idea what any of this was. I was like, okay, well, it seems like it's something serious. He's built something kind of real here. And so let me fold my career essentially as an investment banker. And then I'm going to come help Tendermint and just as like I want to come and operate a startup, essentially. That was like the motivation behind it. And then through that was like in 2018, something around 2017, 2018, something around there. And I just like learned about this whole world of crypto and blockchains and all of it. And turns out my background kind of in systems design and architecture, as well as all the financial work that I did, kind of goes into is very relevant for this topic, essentially. And so, I think you might be muted now.
Oh yeah, I was. Sorry, I was saying it slots right in.
Exactly.
Yeah, that's exactly the combo you need, especially if you're going to found a company in the space as a technical lead, CTO, co-founder type person.
Yep. Yeah. So, well, I'm technically not the technical lead. I'm more of the Rebecca, the CEO, likes to talk and call me the master of coin. Essentially, I do everything around economics, everything around incentive design. Everything around kind of broader strategy of how we should think about things. And so, but all these technical background that I've had in the back, like blockchain, people like to make blockchain sound like it's more complicated than it is. It really is just it's really just a database, right? And it's a distributed database that's not controlled by one person. And there has been architectural decisions that have been made over hundreds of years, or not hundreds, maybe tens of years to optimize and make these things better. And so everything that people talk about today, whether it's DA, whether it's like all these little like buzzwords that people talk about, it's been discovered and already kind of talked about in the Web2 world. It's just now done in a much more decentralized fashion. And so from my perspective, it's like bringing all those kind of knowledges of computer architecture and also bringing kind of the financial side of things from my banking days, essentially, and bringing it all into one cohesive package is like kind of a dream come true in my eyes. And so that's what's really been exciting for me is like, how do we like bring all these knowledges from these industries that has gone through this kind of motion before, and how do we make it so that crypto is better, such that it is we're not just reinventing everything from scratch, essentially.
Well, it's really interesting because I feel like it's rare that teams have someone like you on their team, especially, in your position, with the intersection of experience and skills that you have. Because, blockchains are just databases, but the game theory around how people interact with that and the programs that are running on them is not simple. And being able to identify the attack vectors and even think about that when you're talking about something like token design takes a lot of skill and knowledge, right? Like I'm CEO of my company of ABK Labs, but I'm not the guy who can tell you what the attack vectors are for something like that. I mean, I can talk about them intelligently after my partner and CTO has told me, these are the things that we got to like prepare for and design around. And this is how we do an incentive correctly. And this is how we create a stick, to ensure performance or something like that. So and I do find that it's like often people are so focused on the protocol and like the actual tech, or they're really focused on like the business and like go to market, and they don't consider the token design and how it fits into the technology and the go to market. Cause it makes a ton of difference the way you do this. And actually yesterday we have a sub show called Everything Bagel. And it's all about the intersection of open source software, AI, and crypto. It's specific to like AI and open source and crypto. Yeah. And we had, Greg Osuri, the founder of Akash on. I don't know if you know him, but you must know each other because we tend to make connections.
Awesome guy.
So that was one of my first angel investments in crypto, by the way, was into Akash. And I said this on the show yesterday, it was one of the best angel investments I've ever made, was betting on Greg. And one thing I love about Cosmos is just like the hardcore open source ethos. I live and breathe that. My partner, Brian, I was telling you before the show, helped start the open source movement back in the day. And it's like a core thing. But anyway, another really interesting thing, and you've been here for a long time, like in the space for a really long time, is like the design space has shifted, and there's a lot that's known now that wasn't known. Like when Akash launched, the things they were doing around incentive design were brand new. That was like, we're gonna fuck around and find out if this works, and it worked. But it could have not worked, right? It could have not worked disastrously, and we've seen other ideas like completely not work. So can we talk about that though? Like, what is the thing you guys are building? And then how does Saga help Web3 developers? It sounds like you can deploy multiple L1s is kind of what I was reading. Yeah. How does that work? And then I'm really interested to dig into let's use your example if you can talk about token design and stuff. I'd love to just dig into your brain a little bit about how you guys got from the idea to what's getting executed and tested out, and talk around things you're confident about versus I don't know, FAFO for this idea, we're going to see what happens.
Yeah. Well, I mean, what you bring up is really the crux of how I deal with everything as well. Because as much as I would say, hey, I have this intersection of these knowledges or whatever, I don't know everything. And the landscape of how things shift, there's no way I can know enough to predict everything that's going to happen. So what's important in this space, in my opinion, is the experimentation and the pace at which you can kind of try things out and pivot your direction. And so that's always kind of the way that, at least the mantra of what I follow, which is let's try something. If it doesn't work, we can scrap it. If it does work, great. We'll keep making it better, essentially. And At the end, it will kind of it will feel like we designed this exactly the way it should be from the beginning, but it's not. It's like it's an organic process that every product designer really goes through, right? Which is like you just treat the token economics as a product, and you iterate. You constantly iterate. You make it better. You improve it. You transition it, and that's the way that at least I operate within Saga ultimately. But yeah, let's I guess we'll talk a little bit more specifically. So. I think one of the things that we're trying to do, and it's really hard when I describe what Saga is to people, because they have all these like pre-existing kind of biases of how scaling kind of functions in this world. So today, I would say there's two kinds of scaling predominantly. One scaling is kind of what Solana is doing, which is, hey, I'm going to make my one fat pipe as fat as possible, essentially. That's like their approach. And then there's like, in the world of Ethereum scaling, it's like this like quasi horizontal scaling thing that they have with rollups and like DA and stuff like that. But no one really talks about like, when I say we're more of a horizontal scaling architecture, everyone just assumes that we're like, oh, you're just doing what Ethereum is doing, which is rollups and L2s and DA and stuff like that. When in reality, we are horizontal, but we like the fundamental approach of how we think scaling should happen in blockchains is actually very antithetical to the way that Ethereum is doing it. And so I'll just like float that out there, and then let me describe kind of what Saga is. So Saga is a layer one that launches layer ones, and fundamentally it's like kind of, I would say, what Cosmos was supposed to be, but the issue with Cosmos in general is that to launch a layer one using Cosmos technology takes, I would say, somewhere between 6 to 12 to 18 months of coordination time and effort to bring a chain up, essentially. Develop it, bring the chain up, get enough people excited about it so that you have a staking token that people have value for, you attract validators. It takes about 6 to 18 months. That is not enough time to horizontally scale applications. Your turnaround time for how to horizontally scale an application should be minutes, should be seconds. This is how AWS works, right? Like when you go to AWS and say, hey, I want 2 cores, you run some website and you're like, oh, I need 4 cores. You just go to AWS and be like, hey, I want 4 cores. And it like instantly comes, essentially, right? It's not like as if it says, hey, I want 4 cores. And suddenly Amazon says, okay, we're going to need to go and build a data center that has 2 more cores over there. It's going to take you like 18 months. We're going to charge you like $800,000. Like it doesn't work like that, right? And so fundamentally,
those are the security audits.
Yeah. Yeah, and a security audit. There's like so many
things. They don't have enough people to even do it. They're like, yeah, pay us $1 million and we'll look at you.
Yep. Yeah, exactly.
Because they're so busy.
Exactly. And this is true all throughout every stack. So this is in block production. This is in like bridges, for example. It's the exact same thing. You go to like layer 0 or somebody and you say, or Axelar, and you say, hey, I want bridges. They're like, oh, go into this BD pipeline. We'll talk to you in like 8 months, essentially, right? And so our perspective is, no, this is not efficient. We need to automate all of this pieces. And so automation and making essentially like a product out of automatically launching these kinds of chains is fundamentally what the beginning of Saga was. Is let's take the Cosmos stack and simplify it such that somebody can go on a chain and request using a transaction saying, I want this kind of chain. And then in the background, everything comes online. The bridges, the validators, the nodes, everything. And then you just get kind of what you configured in the front end, essentially. So that's like the technical level what Saga is.
Yeah, no, I really love this. And it's something you probably didn't know because I haven't really talked about this that much. But it's a core problem that I actually started working on in June in the Solana ecosystem. So I was at the Solana Foundation before, and I left because they're to start working on enabling people to build permission environments using Solana as a stack. And what I very quickly realized is that like, in order to launch a Solana network, you needed really deep expertise. It's even worse than Cosmos in some ways because
it's not designed for that.
It's a giant mono repo where like Anza knows their way around the main team, like building and maintaining that, but operationally to run it as a network, or even a validator for like a new person coming in, less so much a validator, because if you have a certain level of skills, you can figure that out. But a whole network from Genesis block, really difficult. It takes a really good engineer weeks to just get one up and running. And that's like time that most enterprises or like other people, like indie devs or whatever, like trying to make an app chain or something, they just don't have that kind of time or resource. And so we ended up building for our customers this thing we call SVM kit, which is not as deep as what you guys have done. I can already tell you, but it, basically TLDR, it's like operational tooling. It's we use Pulumi, but we don't support this yet, but you could like use Terraform or any other kind of code as infrastructure as code tooling if you wanted to. But it automates everything from like going from Genesis block to a full cluster to just like a single node, that voting or non-voting RPC node, whatever you want. And like you can launch a whole network in 10 minutes.
Yep.
And the only reason it takes 10 minutes is because that's like literally how long it takes for like the infrastructure as code to get through its processes. Like the commands are like 5 commands. And so it is a fundamentally very similar problem. And I found the same bottlenecks that you just described, like bridges. There's all these SVM chains, and like, how are they going to bridge? And oh, wait, we have to wait like a couple months for layer 0 or Wormhole to like support us. Like that's not a viable option.
Yep, that's exactly right.
There are some people, and it's actually all come from Cosmos, right? The Mantis team, they built an IBC connection for Solana for like an alt SVM or network extension or L2, whatever you want to call it, to like Solana to Solana or IBC to like Cosmos to Solana. They built a bridge using IBC. So what I'm really curious about though is how does the validator stuff work for you guys? Because that's a piece where I was like, man, wouldn't it be amazing if I could just launch a Solana network and all the validators on mainnet were just like validating my network?
Yep, that's exactly how it works here.
How does that work from a token design? Like walk me through that.
Yeah. So what you described is exactly how it works. And so we're taking a different approach than most other layer ones. So a lot of layer ones, especially Solana and Ethereum, even Cosmos, they're like, let's make the validator set ginormous and make it as big as possible. The problem with that is when you employ something like what you just mentioned, and you want to replicate that for every kind of like sub chain that you launch, you're multiplying every infrastructure cost and effort by 100, 200, 50,000, whatever number of validators you have. Yeah. So from the very get-go, right now in our mainnet, we only have 21 validators. We're going to increase that eventually, but we need to get all of the infrastructure pieces ready to automate all of this with 21 first, and then we will start opening it up to hundreds of thousands or whatever if you wanted to. And so generally the way it works is the 21 validators that are validating our mainnet are essentially watching the mainnet for these transactions saying, hey, launch a chainlet. The one big problem essentially that ICS and the interchain security, which is like kind of similar to what we were doing in Cosmos has, is there isn't a defined economic structure that it is set to launch an interchain blockchain essentially using Cosmos. You have to individually negotiate exactly what the rate is that it's going to pay, and with a lot of the time it's like uncertain. It's like in other tokens that you don't know. So what we've done essentially is our model is we universalize this whole thing. It works exactly like AWS, where the validators come together and they like kind of set a price essentially. Let's say it's 10 Saga tokens per month. I don't know what it's probably a lot more than that, but they all come and agree through an auction amongst the validators saying, hey, I'm going to set the price, and universally this is what the price of the chainlet should be per month essentially. And the only thing the user has to do or the developer has to do is acquire that many Saga tokens and put it in an escrow account and say launch. And then essentially it launches that chain, and the escrow balance reduces over time based on how much what the rate is essentially on a daily basis.
Oh, that's super interesting.
Yep. And then when the escrow runs out, the validators shut down the chain essentially. And then you can at a future time, if you wanted to, bring that back online by paying for the escrow again essentially.
So does this mean that if I'm a developer and I'm building my own chain, I've got some custom features to it, right? Like different economics things, and I've got my own token. My chain could generate fees. I could use some of those fees to buy Saga tokens automated right?
Yep.
And pay the validator set.
Yep, that's exactly right. And then like
this is exactly how it should work. You figured it out. Congratulations.
Exactly. Like, and also like this is kind of okay. This is like if you squint a little bit, this is kind of how Polkadot works, but it's flipped. It's like an auction
minus
across the builders.
Auctions. Yeah. Okay.
It's flipped in our model where the validators are bidding. And so the way that our protocol functions essentially is everyone bids some price saying, hey, I can validate a chainlet for X dollars per month essentially. And what the protocol does is it goes across all the validators and then selects the cheapest 21 essentially. And then whoever is the more expensive than that point just kicks everyone else out essentially.
Yeah.
And then the way it functions is the price is set to the most expensive person within that 21 set. So everyone who bid gets greater than or equal to the amount that they bid essentially. And so this auction model is not in yet. Right now, this is like the model that we're building towards.
Well, you know what's interesting? It's interesting because there is a Web2 example of this, and it's a classic customer validation, market validation tactic of A/B testing pricing.
Yep.
Right. And you just like the rule of thumb when you're doing that is if you're kind of flipping on this idea and set, but the rule of thumb is like if I'm selling you a T-shirt and I sell 1,000 and I A/B test $10 for $15. If the market picks $10, then I refund the $15 people. If the market picks 15 though, all the $10 people get 15.
Yep, that's
you know
right.
what I mean? It's kind of the same thing.
Yeah, that's exactly right. And so from our perspective, in the long run, we actually don't think this is going to be the value driver for Saga. So what we want to do is create this like economic model where validators are constantly pushing down this price as low as possible because they're competing, right? Essentially, the ideal position we have is there's like 25 people constantly fighting for 21 spots. If you kind of think about it this way. And everyone is just constantly trying to drive, like, oh, I think we can essentially offer this a little bit cheaper. And let's say you lost a bid, essentially. You're like, how come I can't run my infrastructure cheaper, but these 21 guys can? So you go back in there and you say, hey, how do I make this more efficient? Let me fix this a little bit. Let me fix the costing. Oh, I think we can get it down to lower than that amount. Then you go and bid back in essentially. And this process continues essentially. And it equilibrates to a position until it gets to a point where you choose the 21 cheapest validators in the world, essentially, the most efficient operators, ultimately. And this is the model that we were like pushing towards, which is how do we make block space as cheap as possible? Because most chains out there, their economics is such that it's like gas-based, which means how do I maximize the amount of money that I can get from users? It's like very flipped. We believe that infrastructure is a commodity item. There's no such thing as infrastructure that needs bidding to win and to drive prices up. It should be the inverse ultimately, because like hardware is cheap. Like AWS is relatively very cheap in this world, and so why is it that we're paying like 100-time multiple of what the cost of the actual infrastructure is, when you can set that price lower and you can extract value in other directions, essentially, ultimately?
Well, it depends largely on the hardware spec too, though, right? Like Solana, the hardware spec is high. It's expensive. And, as the network has grown, it's gotten harder, especially for RPC. For Validator, less so, but still has gone up. But if you're running RPC nodes on Solana, it's tough. And that's actually a core problem that ABK is working on solving. We're building a protocol and a network to drastically reduce the cost of running RPC on Solana. But one of the other problems that we identified in Solana, that's Solana specific, and I'm just sharing it with you because I think you'll think it's interesting. And Cosmos largely solved this. And this is where I think like cross-pollination in an open source manner between like Cosmos validator tech, and I forget what you guys call that, if it's the Cosmos SDK technically speaking or what, but Cosmos validator tech and Solana, it's a mono repo, right, with a million lines of code. And as soon as you start launching other chains and making modifications, you diverge from the mainnet Agave repo. And it very quickly becomes near impossible to maintain it and keep up. So now you become Anza and you lose all the security benefits of like an open source project very quickly. Yeah. And your upgrade path, like if there's a 0-day bug, Anza patches it, you're fucked because you're not going to be able to patch it.
Yeah. There's so much to fix essentially that you've modified.
Exactly. And this is largely the path that Linux went. Okay.
Yeah.
We believe that you need a modular client. and you need to basically strip out. And what we proved you can do is you can strip out. There's these things called policies that define how the validator behaves.
Yeah.
You can strip them out and make them plugins that live on the chain. And they load from either your side, your chain, like your fork, or they can load from mainnet, like however you want. And then once you get that in place, then you can potentially start doing some of the stuff that you're talking about with Saga, where like a node on a network, because it's just running the kernel of Solana, can validate multiple chains. Potentially as a single node or maybe like a cluster of nodes, but it can like, I don't know exactly how the architecture would work out, but that's our vision. Like long-term, ABK Labs wants to build that as an open source project. I think we can make a lot of money doing it. I think there's some token economic structure we could do, but really just because we think it needs to exist.
Yeah.
Right?
I agree. But it's one of those things where Cosmos started as this modular, like framework essentially. There's problems with Cosmos too. Let's not. I'm not saying it's like there are modules out there that literally every Cosmos chain uses, because once you try to modify that one thing, you have to modify like 15 modules in the background, and so there's other issues as well.
Yeah, so it starts to feel not so modular at that point.
Yeah, it's not so modular because like everything has like these interdependencies in the modules essentially. But as I said, it's a good goal to have at least. So like the nice thing, it is really nice building in this Cosmos world, because from our perspective, it's like whenever we generally think, hey, like there's this like thought of how to improve like certain parts of our stack, somebody has already done it before. And so we have like lots of reference implementations that we can go through and see, hey, is this what we want? Is this not what we want? And compare and actually pick and choose essentially which implementation is closer to what we want, and then we can also modify ultimately. And so that's kind of the nice thing about Cosmos is it's so decentralized, and this like entire modular framework has existed. I think like with Solana, as mentioned, like the goal from the very beginning was like one fat pipe essentially, right? So it's like, yeah, the fat pipe's awesome. But if you want to make parallel pipes, it's like it gets a little bit more complicated, right?
Well, I think one of the interesting things I want to point out about Solana, though, yes, that was the goal, right? Blockchain at the speed of light, NASDAQ, on chain, right? But one of the cool things about Toli is he is an open source maxi, right? Like he believes in open source. And so I think his vision has always been, and he has always encouraged people to experiment with Solana and do different things. And I think it's exactly that ethos that will lead to an improved, more modular Solana that will improve mainnet, right? It will enable, like if you go the way of Linux and you have a modular stack, it actually makes it so that like you can get more and more granular. And that's what you have to be in order to optimize to make those pipes bigger, ultimately, I think. And maybe I'm totally wrong, but that's my intuition / experience from other people who, were there when Linux was built.
No, 100%.
Like that's, the history does repeat itself
more
in that
than
way.
just Anza like doing this, right? You want like multiple people looking at this at the same time.
And they are now, and that's the cool thing. Like it is really cool that's happening. Like there are many clients now being built. Many really interesting, talented teams looking at it. One thing I'm really excited about this conversation with you is just how we have looked at the same problem just from different ecosystems, and probably with some different needs. Which it's like cool to talk to somebody who really like dug into that and has figured. Like I do think it's going to work. Like I don't know how far along you guys are in this experiment, but everything you're saying to me, it's like you've looked at the problem correctly, you thought about it from first principles, you designed a system that could work. Like how far along are you now? Like where are we today on whatever today is, sometime in February, mid-February?
Yeah. So right now, the basis is all there. So here's, you can go right now on Saga, app.saga.xyz, essentially put a transaction in to launch a chain permission. Right now it's permissioned. It uses this like test token called psaga that we control the supply of, because we don't want right now the economic activity of actually like paying for the chain is not implemented yet. And so, but as long as you have these psaga, you just ask us for it, we'll just give it to you. As long as you have that, right now it takes about 2 minutes to launch kind of a chain. It's fully decentralized. It comes with an RPC endpoint. It comes with an explorer, and the chain kind of comes online. We don't really do anything. It just happens magically amongst all the validators that we have like for mainnet essentially. And so the thing that's a little bit more complicated with this is, so in the beginning, what we were thinking about was, okay, people will launch their own chainlets, the projects that are building on Saga, and they will attract liquidity themselves. So, like our big focus for step one was just the validator, the RPC endpoints, some of these like very infra heavy things. And then what we quickly realized is like this liquidity issue and the fact to bring like bridges and all that is the exact same problem that we had with the validators essentially. And so we're in this stage where we're kind of launching mainnet essentially 2.0, where when you launch this new chainlet, it actually comes with what we call liquidity integration layer, which is short for, you can shorten it to LIL, we call it LIL. And essentially it's like a bunch of, not only when you put that transaction in to say, hey, I want to launch my chain, it launches the chain itself with the validators, but it also stands up all the bridges that connects it to every other chainlet and to connections to like all the Ethereum ecosystems. But also it automatically stands up all of the infrastructure needed to automatically route between them. So you don't have to go to like some bridging website and bridge between the chainlet. It's all
that's
automatic.
Interesting.
Yeah.
Yeah, that's really interesting. So it's like Jupyter swaps where it like routes everything automatically.
Yep.
But you're doing it across multiple chains.
Yep. And so like right now, like instead of like what
do you
ends
guys
up
use
happening,
Relayer? Do you know Relayer? Those guys, they do like, do you know what I'm talking about? Is that who you use for some parts of this, the bridging piece?
So our bridges, because we're using Cosmos, is all just IBC. And essentially in the background, we have all the infrastructure that spins up the relayers needed to make the bridges all function properly. So it's like a little bit complicated. So the way it works is, let's say
okay, so it is a Cosmos fork. It's you're building off of Cosmos.
It's all built on Cosmos. This is like
cool.
This is
we
all
never actually
built
explicitly
on
said that. I kind of assumed it.
Yeah. Well, I mean, like
cool.
I'm wearing like here. I have a Cosmos shirt.
I can't see that. Cosmos shirt. There. Yeah.
So
we're on Cosmos, people.
Yeah. But it's like we're like a weird subset because we're like EVM Cosmos. So we're like aligned with a lot of the Ethereum communities, but our tech in the background is kind of invisibly all Cosmos, which is like kind of cool in my opinion. And so I was saying something. So everything is all the bridges automatically get stood up. So like let's say we go and launch ABK chain. You request an ABK chain. In the background, as mentioned, all the validators launches a node, connects to one another, and then makes that chain for you. In the background as well, all of the bridging pipelines to bring up all the relayers between this new ABK chain and the router that routes all the traffic across Saga is automatically stood up at the same time. So it literally takes about 2 minutes for you to spin up a chain, have all the bridges necessary to go connect to things that you need essentially. And all of the routing is stood up automatically as well. And so like what we want to do is be able to, for someone to go and launch this, ABK chain, and then immediately using our API and say, hey, bring Ethereum into my chainlet instantly. And then you just put a transaction in, use our routing tools. It will just suck up that Ethereum all the way through Axelar down into our routing chainlet. It will relay that routing chainlet back to your chainlet, and that Ethereum will just kind of magically show up on your chain. And this is like all done. You can launch this in like 3 minutes, and you can parallelly launch 300 of these in the background and suck Ethereum into each one of them individually, and it will all come essentially instantly. And I would say we're like really close to this. We're releasing liquidity integration layer that's coming live like this week, next week, essentially. Our first instance of this with Uniswap and Oku is going up immediately after that. And so really close to all this. And then there's some like improvements we need to make in the user experience front to make this happen. But like this will kind of kickstart a lot of the DeFi activities that are happening in the chains that people have been asking for, is like, hey, how do I get liquidity onto these chainlets that I'm launching essentially? So
what's the scalability like from a transactions, TPS thing standpoint for you guys?
So TPS, Okay, I would say TPS is almost irrelevant, but it's like, let's assume, for example, I don't know what the actual metric is, but let's say we can shove like a small number, let's say 100 TPS onto a chainlet. The way that we think about this is an application should actually start sharding its application across multiple parallel chains. Because if it only takes 2 minutes to launch a chain, essentially, you can dynamically figure out when your application is getting congested, right? And start spinning up backup chains in the background. And so this 100 TPS eventually will start incorporating a lot of innovations that are happening in Cosmos space that brings that up to, a few thousand TPS easily, right? But in the meantime, you can just scale this as much as you want, right? And so one example that I've been talking about, I just talked about Uniswap, right? I'm working essentially with the idea that we can start sharding Uniswap instances in the background in Saga. So Uniswap is going to go on live on a singular chainlet pretty soon in Saga. But you can imagine like an easy ways to do this would be like you take one pool, let's say USDC, USDT, and you stick that into a separate chainlet in the background, right? And you can start parallelizing every single one of these pools that you have in Uniswap can now go on individual chains in the background, right? And then you can also, that's like step one. Step one is just like a one pool per chainlet, like sharding essentially. Step two is you can start actually sharding the same pools onto multiple chains. It's super easy to do. The reality of it is not everyone needs the entire huge ginormous pool liquidity that Uniswap pool has, right? Some people are doing like 1 ETH transactions and other people are doing like 100 ETH transactions. The 1 ETH transactions can go into a Uniswap instance that has a smaller pool and it won't affect the slippage as much. So you can actually start splitting out one pool into parallel versions of this. Like think of it as one small pool and one big pool. So now you have doubled the amount of capacity, but you only increase the liquidity by like 5% or something tiny essentially, right? And you can do this in multiple times. So now you can have 10 or 15 small pools that people get routed to for transactions. And then only the big transactions go to the big pool, essentially. And you can do these like dynamic routing, essentially, that allows you to shard Uniswap almost like infinitely. And this is like kind of the vision of what we have. It's like, look, this is how scaling should happen in blockchain. And this is the design philosophy that we have. And it's like, how do we enable this to happen? And so we're going to start with Uniswap. Other stuff is going to happen, and I'm hoping that we can create an SDK that allows people to just parallel shard applications automatically, essentially.
Is the Uniswap like a formal partnership with them, or did you just fork it?
No, that's the funny part. No, we're just it's not really forking. So we're going to shard them regardless if they want to or not.
How does that work?
So like Uniswap, the DAO essentially has ways to deploy Uniswap contracts, like canonical Uniswap contracts, and they own the actual contract itself. And so from our perspective, or from their perspective, when there's two Uniswap contracts that are canonical on Saga, they'll just treat it as two different chains in their heads. But like it doesn't really matter if it's the same ecosystem or not. They just, now they have double the amount of instances that they need to like think about, but they have a process for this. So we'll start with a singular Uniswap chainlet, and then later down the line, we're going to identify one pool to like split out and say, we're going to deploy a second Uniswap chainlet and we'll apply again. They'll say, yes, that this is now the canonical Uniswap chainlet, except now there's two Saga essentially. And then we'll just keep doing that. And actually, in fact, I actually prefer not having this partnership because.
But you still have to ask them for permission to use it, though. Like it sounds like you go to them.
Uniswap is an open source software, right? There just is controls.
I thought they were
around,
like that. Yeah, that BSD license thing, right? With like part of it, right? Wasn't it? And so then it becomes open source later, or what's the deal?
No. I'm pretty sure Uniswap is fully open source. Yeah,
okay.
So,
I couldn't remember.
Like anyone can use it.
I feel like there was a thing where they changed it after a while or something. I might be totally off on that.
Yeah. But as I said, like from my perspective, it's like anybody who believes has an open source software that's a Solidity smart contract, we'll just be able to work with them to deploy one version and then shard it to like hundreds and different chainlets in the background. And there's some complications, right? So like the front end needs to know that when they receive a USDT to USDC like transaction, to route it to the correct chain. And so we just need to put some piping in the front that allows them to multiplex that, and then it's like pretty simple after that. You just kind of shard it to like however many that you want, and then direct traffic in whichever direction you want to ultimately. And so,
it's super cool. We are at the top of the show.
Oh, sorry.
So I was just going to ask, like, the last thing I ask everybody is, what have I asked you that I should have asked?
What have I asked? Oh, I don't know, man. I think. I really like the fact that you're thinking about how to make Solana more modular and more parallel. And I think a lot of folks I don't think people quite understand the power of horizontal scalability. A lot of people, because how people always talked about like horizontal scalability. It was existing. Like Cosmos has existed since like 2018. It's like technically a horizontal architecture, but having it kind of available as something that comes up like in minutes, right? It's not something that has existed before. And I think we're going to see a pretty big swell, like a transition essentially of how developers think about applications once like this paradigm exists in this blockchain world. And so I don't know, like question wise, what would I say? Like maybe if you asked more about like horizontal design, there's like some interesting stuff we can talk about, but I feel like, as I say, we don't have that much time. And so
it's a rabbit hole. I mean, what I'll say is I think this is why Cosmos people and Solana people like each other so much, is because we share this true open source ethos.
I love Ansel. I met Toli before Solana launched, actually, and I sat down in the office in San Francisco with him, and I think it was him. He like was explaining how like the Solana like block production and the catch-up mechanism for verifying the blocks, how there's like two different points that like moves along in time. I was like, oh, this is really interesting. I think like ethos-wise, we're very aligned. And it's just slight variations on like how we think we should prioritize the scaling ultimately.
Yeah.
But yeah, I think you're right. It's like
my point about that is that like it just makes these conversations so much more fun. Like the why for ABK Labs is just build together. That's what I want to do. I was working at the Solana Foundation, I had a great job, but I wanted to go build something important. Like I was like kind of worked myself out of the job there, and I loved it there. But I wanted to do something more impactful. And the most impactful thing I can think to do is build open source software with great engineers and people that I like.
Actually, I'm going to say this. There's like something here, in my opinion. So, you know how our system is a chainlet L1 to launch L1s essentially.
Yeah.
So, the way that our tech stack is kind of implemented actually is it's all containerized essentially. Like the chainlets are all containerized, and so the consensus algorithm and the technology stack that powers each chainlet actually doesn't have to be the same. So as long as each of the containers speak the same language, in our case, it's IBC, and it's there's like certain other things that it needs to adhere to. But if we can design essentially a Solana stack that adheres to those languages and models, we can actually launch a full Solana stack chainlet essentially, and parallelize it. And so, as I said, it's exactly as you mentioned. There needs to be work to make Solana a little bit more modular, where it's easier to do this. But once that step happens, we can deploy, infinite numbers.
That would
of
be
Solanas
really cool to explore, because I think we could do that with you, because we've already got SVM Kit, which is like that operational tooling for the deployment part.
Yep.
But the piece you have is this like interop and the chainlet idea and the economics piece. That's like the piece that we are really missing.
Yep.
And again, for us, it wasn't. Nothing we've done has really been about making money or like building a token or anything like that. It's literally just been like, I want to build open source software. We're going to figure out how to fund that. That's my job. I'm CEO. That's like literally how I view my job, is fund engineers making open source software.
Yeah,
that's it.
Yeah,
so we should explore that.
Chat. Yeah, of course. I mean, as I said, it's a. I don't wait. Did you say somebody had a connection, an IBC connection to?
Yeah,
Solana,
Mantis.
Or?
Yeah, it's already built. There's one built. So there is a way to do a alt SVM chain or network extension bridge to another SVM chain, mainnet or another SVM chain using their stuff. Like it hasn't been like, I think there's just, I don't know if it needs to be, if it's as automated as what you have, where we could just like easily configure it to do what you're talking about. Because the thing that you can do really easily right now, you mentioned about like the different consensus stuff and like the modifications and things like that. That's the piece that's still kind of hard on Solana that needs to be like innovated on, I think, to really make a Solana Saga product work.
Yeah.
You gotta cross the chasm there and meet in the middle somewhere to like really be like, okay, we've already got it down so you can launch chains really fast, but not where they're like automatically connected with the bridges and the routing and all that stuff.
Yeah. I mean, even in Cosmos, which is designed to do this, it's like it's a lot of work to do this. We've spent significant engineering cycle because like there's like really dumb problems that come when you do this. Like for example, when two chains come online, sometimes the tool will make like 3 bridges that are like parallel and doing the same thing. And then all the tokens that are going between the 3 bridges, it's like not fungible with one another. And then it's like everything breaks, right? And so we have to make sure for it to check that like there's only one bridge that it's using essentially. Like there's all these like things that come up that like are problematic to automate essentially. And so this is like, as I said, like from our perspective, I think this sounds to me like something that we can work together on, which is like really exciting in my opinion.
Let's do it. That's why I love doing this show. Thanks for coming on. I appreciate you.
What's up? Yeah. Thanks, man. Appreciate it. And let me know if there's any other questions and I'm happy to answer.
I will do. I guess the last thing is, how can people reach out to you?
Easiest
to get involved.
To get involved? I mean, if you just go to our website, Saga.xyz, there's all the contact forms. Feel free to reach out to our team and somebody will definitely contact you. So
awesome. Saga.xyz.
Yep.
Thanks so much.
Hey, thanks, man. Bye-bye.